Hi, everybody. Hope you can all hear me. Welcome to this webinar. Sorry to keep you waiting a few minutes. Let me first introduce myself. I'm Josiane Barreira from Siemens Austria. I'll be moderating the webinar today. So if there is any questions, I'll be the one looking. You can post it on the chat. And so to introduce this webinar. So this is part of a series of webinar organized by the IDSA in the scope of a Horizon Europe project called DataBri-X. There has been already previous webinars related to the project. We will encourage you all to take a look at them when you have the time. So today in the DataBri-X project, we have 3 use cases. So today we'll be talking about one of these use cases, which is the energy data space, which is in the project leading by Siemens, which I'm part, and this my colleague Konrad Diewold, which is also working in the project. He's going to present the use case. I think we plan for 20 minutes presentation plus questions, or 30 minutes presentation plus questions.
Yeah, let's see where we get to.
Yeah, so please, Konrad.
Okay, hi everybody, I'm Konrad, and welcome to this talk. So let's see if this is working. Okay, why is this not working? Next slide. Okay, here we go. So first I'll tell you a little bit about the Siemens AG. So as Josie said, we are from Siemens AG Österreich, but I'll tell you in general about Siemens AG, then about DataBri-X, then the use case that we brought into the project, and then a quick summary. So the motto of Siemens is to generate technology to transform the everyday. And basically, you can see this in the statement of our CEO, Dr. Roland Busch. Basically, digitalization is the backbone of our economies, and therefore we are looking into that in the context of industry, infrastructure, mobility, and healthcare. So we're really trying to make things, transform things into the digital realms across these and automate, so to say. We are a rather large company, so we have a lot of employees, span across the whole world, so to say. We are located in Austria. And just to give you an idea on what we are working on, so these are some innovations examples that come from Siemens and that we are currently looking at and working on it, that basically also show you how to say the different levels we are looking at. So we are looking at, on the one hand, of course, hardware, and then also software running on that said hardware. On the one hand, that's very low level, so to say. And then on the high level, it's also about how can you track the carbon footprint through value change and then optimize this. One thing that we are trying to achieve is, and that we're kind of very passionate about, is making energy systems more renewable and more reliable at the same time. So basically increasing the renewables that we have in our energy systems and providing solutions for that, because that of course also impacts the control mechanisms required in order to get wind and PV into our system. So here as a third thing, you can also see reliable power via renewable energy generation. I should say that while we have business units that basically sell our products, Josie and I are not from the business units. We are working in T. T stands for technology, and formerly it was known as corporate technology, which is the R&D branch of Siemens, or within the Siemens AG. So basically, we are doing research, looking at technologies, evaluating them, and then seeing to what extent we can basically get them into Siemens products in the future. In that respect, we've been working on the energy domain now for a very long time. We've been looking into energy automation, and in that context is also where our proof of concept and pilot is located in the project. So let's briefly talk about DataBri-X, what DataBri-X is. As Josie mentioned before, it's a Horizon Europe project that started approximately a year and 3 months ago. And the idea is the following. Here's basically the overall architecture that was proposed in the project. When you have data-driven problems that you want to solve. So for example, think about that you have data sets where you want to extract some knowledge and you want to analyze those. This is usually associated with a lot of manual effort. You need to basically put the data through many services in order to get the results out that you actually wanted. Now, what DataBri-X wants is to basically develop a new governance process and also associated services to tackle exactly these problems. So the idea is that you can define a process of dealing with your data, and this is then automatically implemented, and the workflows are basically executed on your data. And this basically connects to the data space in such a way that the data space is the source and also often then the sink of the data. So before the process, where does the data come from that is used in the process? Well, out of a data space. And again, the data can be fed into a data space after the process has been completed. So that's in a nutshell what DataBri-X is about. As Josie also mentioned, there have been past webinars on DataBri-X, and you can find these on the archive side of the IDSA. So here are some links for you. The videos are available on YouTube, and you can also find the PDF handouts of the slides. So that will bring you up to speed. What Josie also mentioned, and these were the things that were shown in the past, is that there are, besides the energy pilot, there are two other pilots. One pilot concerns analyzing information on a telecommunication company, Nova. So that has been shown in a video. And another one concerns the ability to use the DataBri-X toolbox to generate the first legal data space. That's together with Walter Kluwer. And again, this is something that you can see in the archive of the IDSA. And the first talk that was given in the context of the project and within this webinar was, of course, to showcase the governance process and the toolbox that we have in mind in the context of the European data spaces. Again, this is something that you can find in the archive. So that's all I wanted to say about DataBri-X for now. Let's head into the energy communities use case. As you all know, the European goal is to increase renewable energy within our energy systems to get less dependent on gas and other means that are not really sustainable. So there have been different initiatives in order to increase this. And now if you are, for example, a house owner and you have a PV system on the top of your house, then it's maybe not that easy to sell this energy, right? Because you only produce a very small quantity. You can be part of a virtual power plant or an aggregator that basically buys the energy from you and from others and then sells it in higher quantities to maybe realize some ancillary services towards the distribution system operator, or you can sell your energy elsewhere. But this is kind of something that takes some time. And now the idea was here to basically provide a new tool, so to say, or way of selling and buying energy from other entities within your community. So the idea is here that if you produce energy, to provide a very easy way of selling this energy to somebody close to you that might need this energy at times. What this basically does is, on the one hand, it will lower their energy bill and you will earn some money. On the other hand, what you can achieve with something like this is that the energy is consumed where it is produced, which is very nice for our grids because, of course, you can then reduce congestions that would happen if the energy would have to get out of the one distribution grid and into another one where the power flows are then reversed, and this kind of leads to all sorts of troubles. So in the end, it's nice because we can increase the renewables in grids and give people or entities the possibility to basically trade energy amongst each other. So this is what energy communities are about. Now, energy communities, here you can basically see the rationales that I've been just talking about. Energy communities are kind of very loosely defined. What does this mean? So everything and nothing can be an energy community. Of course, there are some regulations on who can be part of one. These have to be small to medium-sized companies only or individuals. But other than that, the configuration of an energy community is not set in stone. And this makes this flexibility is great, because if you come up with a good strategy for an energy community and you're able to implement it, then this is something really good. On the other hand, it makes the evaluation of whether or not an energy community is really, sufficient economically, something that might not be that easy to evaluate by just looking at it, because of this multitudes of configurations something like this could take. To show you this or demonstrate this, here's a short video that I hope I can play. Yeah, so this is a simulation environment that we're using. And basically what you see here is an energy community, a very small one. It basically just has two participants. So we have this public swimming pool on the one hand, and then this house on the other hand. And when the public swimming pool produces energy and the house requires some due to, it requires some, then basically the energy is shared. Now this would be one configuration. Another configuration would be to say, well, actually these two participants should share. Or other things, sharing, so to say, energy, other entities sharing energy with each other. And depending on which entities you basically have within your energy community, it might make more or less economical sense. And the question is, so what's a good configuration? Because once you come up with a good configuration, you can basically contact these entities and talk to them and ask them whether or not they're willing, and also show them what kind of benefits it would give them to be part of this energy community. Now I would like to talk to you about how we will implement this proof of concept. And we will implement this proof of concept using our virtual testbed Bifrost. So as I said before, we've been working in the energy domain for the last 15 years. And one thing that we see now more than ever is you implement an interesting solution, and then it's really hard to demonstrate it, because in the best case, nothing will happen, because all the problems that would show up on some monitor are actually not shown, because your automation solution solves these problems. And just a green blinking light is not really something spectacular. So we needed something else to showcase the things that we're developing in our smart grid test bed. So we built a co-simulation environment that was specifically developed to build scenarios, simulate them, and also present them, and present what impacts they have for different users and stakeholders. This tool has been in development for the last 4 years, and there have been several releases right now. And we've been actively using it in order to showcase what Siemens technology can do in the context of this transitioning. And if you're interested in exploring it, I welcome you to go to bifrost.siemens.com/transition report. This is basically, it looks a little bit like a computer game, but there's a real load flow simulation running in the back, and you can really discover aspects of energy transitions and how technologies can, improve our energy systems, and what technologies can do for us, and how the smart grid can really impact this. Now, what do we want to get out of DataBri-X? As I told you before, DataBri-X is basically a governance process and toolboxes, so to say services, that allow you to solve any data-driven problem. Here I put for you on the slide the distribution of time, effort that we are currently facing when we're implementing a new simulation for Bifrost. And as you can see, the majority of the share is actually not lost, but spent preparing the data. This means finding the suitable data for a simulation. Depending on what you simulate, you might need different time series. Then preparing those, they might come in different forms. You might need to prune them. You might need to find out whether or not all the values are correct so that your simulations are correct. This is really a lot of time that goes in there. A colleague of mine had to prepare something, I think a month ago, and he spent half a month for a rather complex scenario. And most of the share of the time was really spent on data problems. And this basically connects us back to DataBri-X. Of course, also finding the data is an issue, which connects us to the data spaces. And then the other things are also taking time, but not as much. So preparing modules, you might want to simulate different PV systems. So for these, you need different modules. You might need to code them, but these things basically have been decreasing over time because in the past, we've used it a lot and we are basically saturated in terms of modules. We have everything for now that we need for our simulations. So this is not something that might increase. And then of course, preparing the scenarios. As you've seen, you can build basically a settlement and then simulate it. And then of course, running and simulation will also take some time. But this is mostly due to the time efforts it takes to then run such simulations. And depending on the horizon that you simulate, so if you simulate a year or even longer, this might take a day or two in a cluster in order to get everything basically simulated and done. Now, what do we want to focus on in the context of the energy communities? As I told you before, what we want to do is we want to basically, on the one hand, so there are two things that we want to tackle. One is the design phase. That's what I showed you before. So basically the question, what's the impact a community setup has on different levels? So what does this mean for a participant? How much energy are they possible to sell? How much energy are they possible to consume? And maybe also, what does this mean for the grid operator in which this energy community is housed? So what does this mean for the cables? How much, is there some concentration that is unhealthy for the grid equipment? Is everything fine? All these things we can basically quantify with the simulation. And this helps then in the design phase to basically quickly figure out whether or not a community in a given configuration makes sense. The second aspect that we want to look at the later stage, so we're currently focusing at the design phase in the project, but once this is implemented, we'll look at the onboarding. So there again, let's say that we have a setup that needs implementation. Then we need participants that need to be integrated into an energy community. It could be also an energy community is up and running and you have new participant that wants to integrate into that. So there, again, this is a problem where a lot of data is needed, interfaces are needed, and this is currently also something that is associated with a lot of manual engineering. So to test if the integration will be successful, etc. Again, this is something where such data-driven methods and also the data that are provided by DataBri-X in combination with data spaces will help us in order to ease those manual efforts and make these things at least semi-automatical. So what do we want to do? Well, we want to utilize the data space to design an energy community and quantify its impact. And we also want to see to what extent we can use this to automate the onboarding process and integration tests. The challenges are these, that we have data sources that are very heterogeneous and that data access is very heterogeneous. So when using a data space, we hope we can mitigate the second, because then we have data access via a data connector. The data sources, however, will stay very heterogeneous in terms of what they are, right? Because just because I make a data available on a data space doesn't mean that it is then made available in a format that as required by others. So this transformation that I was talking about, we might still need. And additionally, one other challenge is that the data that we actually need really requires heavily on the application scenarios and KPIs. So if you want to look at a simulation from the viewpoint of a distribution system operator, then we need data in a different resolution and form than if we are just interested in a very rough estimation and heuristic on how much money can be gained via such a for a specific entity in there, which then requires less data, so to say. And all these things basically tie together and require, on the one hand, the data space as a data source, and then of course also as a data sink, and those data-driven services provided by DataBri-X that allow us to prepare the data on the one hand and then post-process it. And this is how we hope that things look like after DataBri-X, so that we were really able to reduce the amount of time it took us to prepare the data. Now this looks a bit, I should have scaled down this pie, because of course the time it takes us to prepare the modules stayed the same, but of course the overall time decreased. So if you would put this pie next to the other pie, this would be way smaller. But in the end, we want to really reduce the time it takes us to prepare the data. And of course, also have something new in there, which is currently just storing it on a hard drive, namely the ability to publish this data. So maybe somebody else is interested in the data later on. So why not put it in a data space and make it available there for the entities? Now I quickly walk you through the user story that we have in mind. And this is really just regarding the design phase. So imagine that we have Alex. Alex is a community operator and they want to present the advantages of an energy community in their hometown to the mayor or to somebody else. So what we want to do is we want to basically be able to configure such a setup via our Bifrost tool. So to say, okay, we are now here in Bad Sauerbrunn, which is in Lower Austria, and we can select entities that might be suitable, I don't know, a restaurant or a public swimming pool, etc. So we want to select them. Then we can basically use this in order to build the environment and the story that we're interested in. This should all be quite semi-automatic, and this is something that we're working on, so implementing a grid from a sim model and these kind of things. And then provide information on these participants. So what is it? Here we have basically a swimming pool. What's the geolocation of it? What are the parameters of this load, or intelligent load in our case? It will also produce energy because it's a PV system and might also need some to heat the pool, for example. So basically allowing us to configure our scenario and then also set the KPIs. So what are we interested in? Is this something that we want to use to present it to the pool owner? Is this something that we want to use in order to communicate with the distribution system operator? These are things that basically impact the KPIs to be set, and also then how and what needs simulation. And then once this is done, we basically have configured our simulation, and then it should be run using the combination of data spaces and DataBri-X and its services. So now let's go from this user story to then the proof of concept system view. So this is basically the sketch of the overall system. So what we have is we basically have models running in our simulator, and we have ideas on the energy consumption. So this is basically information that we have that basically, constraints what we need in order to do our simulation. So we can use this information in order to search the data spaces for specific information that we need. So in our case, this would then be solar irradiation for specific geocoordinates and synthetic load profiles that basically match the energy consumption in our scenarios. So this is the first step, that we basically obtain this information from the data space. Then this is basically put into the DataBri-X framework. And in the first step, the tasks are to pre-process the data obtained from the data spaces and elsewhere. So what are the pre-processing tasks at hand? Well, one issue that we have a lot is that timestamps come in all sorts of colors and forms, and streamlining them across different data sources is really a task that is very tedious. It's not hard, but it's tedious. So this is something that we think can be done via pre-processing. Also curating the data, looking at it, removing other numbers, checking if things actually make sense. These are things that can be done with simple rules, and that's why here we have as one of the DataBri-X services RDF-Fox, which is a triple store with a semantic reasoning engine where you can basically define those tasks and then run them on our time series, basically doing the pre-processing. Once the data is pre-processed, it's basically ready as a unified input for our Bifrost simulation. So this means that then the simulation is run. This might take, as I said before, between a few minutes and a few days, depending on the magnitude of the simulation. And then once the data is ready, so the simulation results is ready, what we want to do is we want to annotate and label the results. This is also currently done by hand. This is something where DataBri-X comes in and its services comes in handy. Another aspect is that we would like to establish ownership and provenance. And then of course, so that others can make sure that this data comes from us and that we can make sure that data used by others is either from us or not from us. So again, we have some tools within the DataBri-X consortium that will help us with this. So we have a semantic middleware pool party with which we can annotate, label, and classify data. We have watermarking approaches within our consortium that allow us to watermark time series and then make sure once we have the time series again, this is really something that was emitted by us. And we have also ledger-based integrity measurements that we can basically use as a service in the context of this use case, making this data ready to be redeployed in a data space where it can then be used by others. So this is basically in a nutshell what we are trying to do. As a summary, so the energy system is really complicated and simulations are, at least we think, that a really valuable mean to evaluate distributed energy solutions. So energy communities are just one of many that basically can be evaluated with such an approach. And what takes the most effort currently is really this data acquisition and preparation, and we want to reduce this manual effort. And I was giving a talk yesterday on this topic, and I was asked, wouldn't it be great if it would be fully automatic? And yes, it would be super cool if we wouldn't require any manual efforts. And let's see how unmanual we can get this whole thing. And what we want to achieve in the context of this project and also in the combination with data spaces is to ease the efforts of these data acquisitions and finding suitable data in the energy data spaces, that we have tools that enable us to do this pre and post processing of simulation data via these DataBri-X workflows. And then enable and share and reuse energy simulation results again via energy data spaces. That's all from my side, except that while we've been now in the first part of these webinars focusing on the overall framework and on the pilots, in the upcoming webinars, we will have a deep dive into the tools. So if this is interesting for you, you're really welcome to join us again mid of February and then mid of March, where there will be tool sessions. So you can, what I've now loosely described in a few sentences, there you get real insights in what RDFFox does, what pool party does, what the Imneda watermarking does, and so on and so forth. So that's quite interesting. And if it's interesting for you, then we'd all be very happy if you could join. That's all from my side. If you have any questions now, I'm very happy to answer them. If you want to write me an email, you can do this via konraddiewold@siemens.com. Thanks for your attention.
Thank you, Konrad. I'm biased, but I think that was a great presentation. I'll open the floor for questions. You can either write it on the chat. I'm not sure if the mic function is working to the non-panelists, but if you can't speak, I think Alex has a raised hand. We can't hear you. If you want to write your questions on the chat, it's probably better. In the meantime, I think, Konrad, you mentioned already something we talked yesterday about having this automatically. I think the other thing we discussed, like the idea of this energy data spaces, right? I think the IDSA it's investing quite some effort there, and there's like multiple projects. And I think it's also what we do here could be like for those people working on the energy data spaces could be useful.
Exactly, yeah. So for everybody interested in this context of the energy data spaces, there are currently a lot of initiatives looking at this from different viewpoints. And there's a position paper that was published by IDSA very recently, where they also look at the various aspects. The thing is that I guess with all things, it's not that easy. Which makes it interesting, of course, because you have a lot of data formats, and then questions arise like, how is it with data interoperability? Because depending on the problem that you're usually looking at, not specifically in the energy domain, but I guess in every domain, you come up with your new data model, and then you have these hundreds of different data models that are made for specific aspects, and then the question is again how to harmonize that, and this is kind of the crucial question also in the context of such energy data spaces.
And I think that, if I may add, so with our use case, we show one use of such energy data spaces, right? That's one of the goals of the pilot, and also
correct,
to be able to speed up our onboarding and our simulations, but also showing that this can be achieved by making use of the data spaces and showing the benefit of the data spaces. It's anybody.
I'm muted now, if I may ask
yes,
a question.
Hi.
Sure.
Hi, now we can
Hello.
hear you, Alex. Please, yes.
Yeah, thank you. Konrad, thank you very much for presentation today and yesterday. I was also watching it. And my question is, why don't we move really much further and create a data space, which is part of the global European data space, when the business case will be slightly different? For example, you mentioned that it takes a lot of time to prepare data. I can imagine. But let's consider the business case when you don't prepare data at all, where every solar panel, where every generator of electricity has its information inside it, and your system simply pick it up from there, just like any other system, because I bet that insurance company wants to see it, or service companies want to see the same data. So that to switch from the modality when you copy data from sources you can reach, to a situation when you reach data where it belongs. In this way, you'll not present data for only one German or Austrian city. You can present for the whole world. You can answer the question, well, how many solar panels are running right now around the globe? And it's quite technically, it's definitely doable. That's what we do at data spaces. But I think that such use case will be really mind-blowing. And we are almost realizing, for example, in cultural heritage, the same problem. You can imagine how many data formats we have in cultural heritage. Trust me, a lot. It's not a problem at all. We know how to deal with linked data, LLM models. Data compatibility is not, I don't think it's a fundamental problem. Does make sense? Shall we talk about it? That was my question.
No, yes, we shall. The thing is, I mean, and maybe also Josie can share some insights there. We've looked into this also, of course, before DataBri-X. So Siemens is heavily involved in W3C things description, right? This goes in this direction. There have been projects, for example, IoT crawler, where the question is, how do I actually find devices and then also then access information on these devices? I think the problem that we're facing, and this might be something also solved with, as I said yesterday, with this upcoming potency of AI, so to say, is that we are still extremely heterogeneous. So you have this W3C consortium that contains Siemens and a few other companies, and they say, okay, we do it with the thing description. And they develop the thing description. But then you have these other people that, out of good reasons, nobody sits down to decide on a new data model if there are not good reasons, come up with something different. And same applies for things like, for example, IoT crawler. So this then works in a very, how to say, restricted domains, because others were not maybe included, don't see a point in integrating there. So, and this is for me the big question mark. If we can, if there's how can we kind of unify these efforts to some extent? I mean, we've seen that in computer. Sorry.
We don't have to do it. For example, in cultural heritage, we have a problem. For example, a museum using, let's say, 20 or 50 different information systems. And of course, every information system wants to write data in their own way. Of course. And the answer is, we let them do it. We let them write data in any way they want, and they will understand each other. That's the idea. So the idea is not to create some universal standard. It's not doable. You cannot create standard for all hotels, or all energy systems, all cultural institutions, all transportation systems. They all have their own data models. Let them have it. So instead of creating unified standards, allow every platform, there are thousands of them, write down data down to the device or organization or person port, as Tim Berners-Lee called it, in their own format. It's absolutely doable nowadays. So let's switch approach. Again, we can discuss separately, but that's the idea. Yeah. Don't create any universal standard. It's
so
a holy
focus
grail.
on the transformation. Okay, understood. Yeah.
Yep.
I guess this is, given what we're seeing, this is the only way forward, that we basically, as you say, everybody can keep working in a domain that they are comfortable in, and on top we have to build a transformation process to make it then usable in another context, so to say.
Yeah, and by any other platform. But Konrad, I'm going to write a problem email later on. We talk. And
yes, that would be great.
With you, and
thank you.
We'll bring some knowledge from other domains. Thank you very much.
Yeah.
Thank you, Alex. There's another question from Edmund Wheeler about real-time data sources. Do we provide support for near real-time or near real-time data sources and sinks?
Currently not. We'll have to see how we do that for the onboarding, because there, of course, the data is continuously produced. But this is so I myself am not an expert in data spaces, I have to say. This is great. Maybe some question also from my side, also then towards the project, how to deal with those. But of course we can always integrate them. But currently it's not really foreseen. So everything that we'll do will be not produced in near or real time.
If I may add, because we mentioned these other efforts like the IoT crawler and like the things description, there are models for this kind of data. I think the storage is it's the data access and the storage is something which you have to figure out. So one way to see it, maybe we can use the metadata for discovering some data source, and then there you will be described how you actually can read this data in real time. But if that's going to be a data space, I think, as you said, Konrad, I'm also not an expert. I don't know if that's planned. Any other questions? I don't hear Olga, but I think then I will close the session. So I just want to thank Konrad again. And thank you all for attending this webinar.
Yeah, thanks for your attention.
Everything will be available online. I think IDSA will provide through the registration. You probably would have access to the slides. We posted some links on the chat. Yeah, and so thank you again, and I hope to see you in the next webinar. Have a good afternoon.
Thank you. Bye bye.
Thank you. Bye.
Bye.